Alright, this is Scientific Notation, Lesson 7.2. You've got a notes handout to record your notes on, so let's get rolling. The learning target for today is for you to be able to write numbers in scientific notation, which is a notation I'll show you in just a second, and then to be able to go back and forth between scientific and the normal way you write numbers, or it's also known as standard notation. And then you'll take this new skill and compare and order numbers in scientific notation. So, scientific notation, as the name kind of implies, is a notation that was developed by scientists who wanted an easy way to record really big numbers or really small numbers without having to write out all of the digits. So, a definition that you can write down in your notes is that it's a number that's written in product form. Remember, product means multiplication. So the number will look like this: some number times some power of 10. And the number part is a number that's going to be between 1 and 10. Now notice that I've put little dashes here. The dashes represent the fact that the number that comes first will be some single digit followed by a decimal followed by a couple more digits. And if it's between 1 and 10, this first digit can't be a 0, and it can't be 2 digits. So it would look like this. A number would be like 9.13, or maybe 2.07. Those are numbers, and then it's multiplied by some power of 10, and the n here would be some digit. So let's take a look at example. Example 1. There are 3 parts to it, and the question just says, is the number written in scientific notation, yes or no? And if it's not, why not? So looking at A, 0.23 times 10 to the negative third. It has a power of 10, and it has a number, but because the number is not between 1 and 10, the first digit is a 0 instead of a whole number. This one is not written in scientific notation because it's not between 1 and 10. In the second example, it has a power of 10, that's right. It has a number that's being multiplied by the power of 10, and it's got something point something. The number's between 1 and 10. This one is written in scientific notation. And finally, the last example, 9.3, that's written in the right form. It's between 1 and 10. But it's being multiplied by some power that's not a power of 10, it's a power of 100. So this one is not written in scientific notation. Okay, now, take your pencil, draw yourself a line straight down through the middle of your notes. Because we're going to focus on the left-hand side all the way down, and then we'll come back and focus on the right-hand side all the way down. As I said in the beginning, scientific notation is a notation to write really big numbers, and in this example 2, part A, 157,090,000 is a really big number. The way you write numbers in scientific notation is to move the decimal point in the number to the spot that makes it fit the form given to you in the definition. So the first thing you do in a problem like this one is find the decimal point. Now this is a whole number, so the decimal point isn't written, it's implied to be right at the end. You're going to take that decimal point and move it so that it sits right between the second digits, right between the 1 and the 5. So all the little marks I'm making, you should be marking on your notes, and you should be marking this on your paper when you do these problems on your assignment. So what I want to do is I want to take this decimal and I want to move it from where it is now to where I want it to be, where the arrow is. And to do that, I have to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So this number written in scientific notation is 1.5709 times however many times I had to move the decimal point to get it to where I wanted it to be, and that was 8. And that number is the exponent on the power of 10. So 157,090,000 written in scientific notation is 1.5709 times 10 to the 8th. So if we look at the examples that follow, the A and C below, these are all numbers that are really big numbers that I want to write in scientific notation. So I'm going to follow the same set of steps. I'm going to put in the decimal point. I'm going to figure out where I want it to go between the first and second digit. And I'm going to count 1, 2, 3, 4, 5. So 678,000 written in scientific notation is 6.78 times 10 to the 5th power. Now you notice in both of those cases I dropped off the zeros. If I wrote all the zeros, then my notation wouldn't be shorter, it would be the same length and even longer because I'd be adding more to it. In the second example, here's the decimal point, here's where I want it to be, and I count 1, 2, 3, 4, 5, 6, 7. So my answer is 5.104 times 10 to the power of however many times I move the decimal point, which is 7. Okay, so what you notice is in the examples that we've done, these really big numbers all have a power of 10 with an exponent that's positive. The positive exponent tells me that the numbers that I've written down are really big. On the right-hand side of the line that you drew, there are numbers that are really small. They're decimal numbers. And we're going to write them in scientific notation using the same method, only we're going to go the opposite direction. This number already has a decimal point, and we want to move it so it sits between the first and second digit that's not a 0. So I'm going to move it between the 6 and the 1, and to do that I have to move it 1, 2 places. So this number written in scientific notation is 6.1 times 10 to the power of however many times I moved it. That was 2. But because the number is a really small number, it's a negative exponent. So it's 10 to the negative second. So right below that, looking at the examples, same method. Here's the decimal point. I want it to go from that spot to in between the first and second digit that's not a 0. So the first digit that I come to that's not a 0 is a 3, and the one right next to it is the second digit, so I move it. 1, 2, 3, 4, 5. This number is 3.02 times 10. I moved it 5 places. It's a really small number. It's negative 5. Next one. Here's the decimal point. Now, the first non-zero digit I come to is 7, and there's nothing after it, so I'm just going to move it to be right after the 7, and I count. 1, 2, 3, 4, 5, 6, 7. 7 times 10 to the negative 7. Now really, to be a little more precise, you could put 7.0, and that's a better way to write scientific notation. Okay, in the third example now, we're going to take a look at a number that's already written in scientific notation, and we're going to put it back into standard notation. Standard notation, again, is just the normal way you write a number. So, 2.96 times 10 to the third is written in scientific notation just by looking at the number and looking at the power of 10 and noticing that the exponent is positive. The positive exponent tells me that this number is a big number. Big meaning bigger than a whole number or bigger than 10 or 100. So to rewrite this number in standard notation, I first write down 2.96. Then I notice that the power of 10 is 3. That means I'm going to move the decimal point 3 places. Because it's a big number, I'm going to move it in the direction that will make this number bigger, and that would be to the right. 1, 2, 3 places. When I'm done moving the decimal point, if there's any open loop, then you fill that in with a 0. So the answer to this is 2,960. So right below it are some more examples of scientific notation numbers that you're going to write in standard notation. But let's move over to the other side and complete the second example second part of example 3. So 1.93 times 10 to the negative fifth, that's the scientific notation. I want to write it in standard form, so I'm going to move the decimal point. So I write 1.93. I notice that the power of 10 in this problem has a negative exponent. That means it's a small number, so I'm going to move the decimal point in this 1.93 in the direction that makes the number smaller, and that would be to the left. 1, 2, 3, 4, 5 places. Anything that's left open, I fill in with zeros. So my answer is 0.00000193. Now what you should notice about both examples is I wrote the decimal part of the number down, and I moved it with the loops, and then I rewrote it. If you show me an answer that has all the loop-de-loops in it and circle it, call it your answer, I don't know if your decimal point is here or it's here. So be sure that when you do the moving of the decimal point that you rewrite the answer so that it's clean and obvious where your decimal point is. Okay, I'm going to end the video here. I'm going to have you finish the last example on your own, and we will discuss that and go over the answers in class tomorrow.